equal to 1 minus alpha over alpha, then we get that 1 minus L is equal to L times 1 minus alpha over alpha. And if we add L to both sides, we get that 1 is equal to 1 minus alpha over alpha plus alpha over alpha times L, which is that L is equal to alpha, and 1 minus L is equal to 1 minus alpha. OK. Yeah, this is OK. So what would a Cheng-Yi, what would a social planner do if they were maximizing utility without any prices involved, as you were suggesting before?
Well, we will have to first decide how much a person's utility means to a planner. So maybe
Let's just assume it's equal for all the people.
Then we'll just have to take into account all the utility functions and do basically a same maximizing Lagrangian.
Yeah, so we know that we can produce according to C equals L, right? So you would literally have the exact same problem as we just did. You would just plug it in directly rather than having this artificial thing of setting up a budget and then doing it, right? The problem would be exactly the same, right? So the social optimum is exactly the same as the equilibrium. So Terrence, is Terrence here? Terrence, to you? No? So why is this the case? Well, the reason is that the firm's rate of turning labor into coconuts is the ratio of prices to wages, right? So this is called the marginal rate of transformation of labor into coconuts. And the consumer's ratio of consumption to leisure, this alpha over 1 minus alpha, are all set equal to that ratio, right? And that's exactly what the social planner wants to do. They want to make sure that the use of time in any activity has the same value on the margin. That's exactly the conditions that we derived for a firm's maximization in when we just did the firm's optimization, right? So if we can always make one worker better off than other workers, as Cheng-Yi said, by just moving money between the two of them, right? So then, rather than having one unit of time, we can just give them y units of time and tax away the remaining units of time. And then they'll just get everything the same, except it will be scaled down in the proportions that they get each of the things, right? So any redistribution can occur from just moving money around. OK. So the only problem arises when equilibrium fails to exist. And a problem with this can arise whenever supply or demand are discontinuous. So imagine that demand was 1 minus 1/2 p. And then we have a firm that can only produce 1 or 0 units at a cost of $1, right? Then note that there's not going to be any equilibrium, right? You're going to have a demand function that looks like that. And you're going to have a supply function that is like either here or here. It looks like that. But it doesn't actually intersect the demand. This is what we were talking about during the last class, right? But imagine that there are 100 consumers like this rather than just one, and 100 firms like this rather than just one, right? then 50 of the firms could produce, 50 of the firms could not produce at a price of 1, and we would have an equilibrium, right? As long as there's an even number of firms, we always get an even number of people in firms, we always get an equilibrium. And if there's an odd number of people in firms, we're going to get very close to an equilibrium. What will basically happen is rather than there being this big jump here, if there's even, we'll be able to do that. If there's 3, we'll be able to do any of these points, right? And as the number gets more and more, there's going to be more and more points we can do, and this whole thing's going to sort of get filled in. OK. So what that tells us is that when there's a large number of firms and a large number of consumers, then an equilibrium always exists. And given that we're only going to really apply the notion of perfect competition in a case when there are lots of firms and lots of consumers, in practice, there's no problem with equilibrium existing. When there's a small number of consumers or firms, it's better to apply a concept like monopoly or oligopoly. And so you're never going to really need to worry about this problem of whether an equilibrium exists. OK. So now I want to move into a world where firms are producing, as we just talked about in the simple Robinson Crusoe economy. And we said that in a world where people just have endowments and they're just trading, the benefits from trade come from mismatches between people's preferences and endowments that trade can correct, right? Now, Jackson, what, when there's production, is another source of gains from trade?
So now instead of people just having differences in preferences, they also have differences in what they can produce, which allows them to specialize in what they're better at.
Yeah, and what's that usually called?
Comparative.
Yeah, comparative advantage, exactly. So an example of this is, if Brazil is great at growing sugar, but not so great at making computers, maybe to make a computer, they'd have to give up 1 ton of sugar, right? Now, China is not so good at growing sugar, but is quite good at making computers. And so they only have to give up 1/10 of a ton of sugar to make a computer, right? Then we say China has a comparative advantage in computers, even if China was cheaper in absolute terms at producing both sugar and computers, right? So China could have an absolute advantage in both, and yet still could have a comparative advantage in computers, while Brazil has a comparative advantage in sugar. And regardless, everyone's going to do better if they can both focus on what they're best on. So China on its own could produce 100 computers, and if Brazil on its own could produce 8 tons of sugar, well then China could produce 10 tons of sugar. So it's just much more productive than Brazil is. But together, they would be capable of producing 80 computers and 10 tons of sugar, which neither of them could produce on its own. On the other hand, China on its own, if it wanted to produce a combination of the two things, would have to produce 50 computers and 5 tons of sugar. And Brazil, to sort of get something similar, would have to produce 7 computers and only 1 ton of sugar, right? And if you pull those together, they get like 57 computers and 6 tons of sugar, which is much worse than 80 computers and 10 tons of sugar, right? So this is very analogous, I think, to what happens in the case of just pure exchange. In the case of pure exchange, every consumer gets to trade for the thing that they like the best, right? Here, everyone gets to produce the thing that they're most able to produce. And that makes everyone better off, right? So just to give you a picture of what I was just saying, China, if this is computers, might be able to produce 100 or 10 bushels of sugar. Brazil might be able to produce 8 tons of sugar or 8 computers, right? And imagine the countries want to have some of each, right? Then they would end up producing here, right? But if they get together, then instead what they can do is have Brazil produce all of the sugar, and then China produces computers overwhelmingly, and then just the little bit of sugar that they need in order to satisfy their joint needs, and they're able to get a lot more than they were able to get separately, because most of the sugar production is occurring in the country that has to give up fewer computers in order to produce the sugar. Okay, so now suppose that in each of the countries there are different groups of people who own the farms than who own the factories, right? Now overall, the economies are going to produce more and everyone's going to be better off if we can trade. But remember that originally, the price of sugar in terms of computers was going to be 10 computers to get a ton of sugar in China and 1 in Brazil, right? So now the prices are going to be somewhere in between once they're trading with each other, right? So maybe it's 5 computers per ton of sugar, right? That means that a Chinese farm owner's price has now gotten cut in half, right? They're getting half as many computers for every ton of sugar they produce. On the other hand, a Brazilian factory's owner's price is, in terms of how much sugar he can get for his computers, has fallen by 5 times, right? So the Brazilian farmers and the Chinese producers are going to be better off by even more than the other people in their country are worse off. So there's overall a social gain, but there's a loss to the person who's the scarce factor of production, right? If you're a factory owner in Brazil or a farm owner in China, you're worse off as a result of trade. And this result is called the Stolper-Samuelson theorem. Now, economists often advocate that we should just compensate the people who lose from trade. But the problem with this is that if you started doing that, there might be all sorts of people who would seek protectionism, not because it was beneficial, but just because they then wanted to get paid off for opening trade up, right? And if you start paying off all these businesses just to get them to agree to trade agreements, that creates all sorts of perverse incentives beforehand, right? And that means that we don't fully compensate people, and that leads to lobbying by the people who have the scarce factor of production to try to prevent trade from occurring, right? Now, that is the usual explanation that economists give for why, nowadays in the United States, labor is a relatively scarce factor compared to, say, capital, whereas in most developing countries, capital is much scarcer than labor. And so usually business owners in the developing countries and labor unions in the United States are both opposed to free trade, because the businesses in the developing countries don't want the competition, and the labor in the United States doesn't want the competition, right? Now, some political scientists have even used this as a way to explain